Hello, dear friends. My name is Elina Belevskaya, and today I represent you Humatex Rosatom, the company that produces composite materials in Russia. And today we have held the panel discussion, Composite Materials at the Cutting Edge of the Progress. And I would like to give a word to our moderator, Yuri Svistunov. He is Deputy General Director. He is by Zoom today with us. Yuri, welcome.
Everybody who joined the conference, the panel discussion, welcome on this exhibition and welcome on the panel discussion with the name Composite Materials at the Cutting Edge of the Progress. We are here at EXPO 2020, not all of us. Unfortunately, we have to hold this, let's say, hybrid format because of the pandemic and because of the fact that not everybody was able to come to the exhibition. So some of us will attend online, some of us are sitting in the hall, as I see on one of the cameras. My name is Yuri Svistunov. I'm the technical director of Humatex, and I represent, as well as Elina, the Humatex company, that is the composite division of the Rosatom company, Rosatom Corporation. And let me introduce the speakers, the attendees of the panel discussion that we have today. I did not sort them online and offline, so they are mixed. First, Vittorio Torombini, the president of the Association of the Italian Entrepreneurs in Russia. Vittorio.
Добрый день. Good morning.
Anton Moskvin, Vice President of Rosatom Overseas.
Good morning. Good morning.
Luca Burelli, Sales Manager, Fiber Industry Italy.
Good morning.
Good morning. Manuel Puccetti, Team Leader Kawasaki Puccetti Racing Italy. Good morning. Brian Gillen, Research and Development Director, MV Agusta Motor Spa, Italy.
Good morning, everybody.
Good morning, Brian. Valery Gurinovich, Director General, Galen.
Good morning, nice to meet you, everyone.
Good morning. And Albert Nazarov, Managing Director, Albatros Marine Design.
Hello, good morning.
Good morning. So fortunately, everybody is here. And then let's start. Let me give the short introduction and explain why do we discuss composites. We know that now there is Rosatom Week at Dubai Expo 2020. And I will give a couple of words regarding the subject of the discussion. Composites are the key materials for the development of the most sophisticated industries. And we know that Rosatom has been actively developing high technology businesses over the past years. Rosatom is a global technological company. It is not only the nuclear energy company. So that's why Rosatom just could not avoid taking a part of the business related to the high technology materials and especially composite materials. And we know that the most sophisticated industries like aircraft building, unmanned vehicles, speedboats, trains, electrical cars would not be engineered, would not be constructed without the use of composites nowadays. So now we are within the Rosatom big family, I mean composite materials. We are a small but very important part, very important piece of this puzzle, this technological puzzle. And that's why we propose today to exchange the ideas and to exchange our thoughts about the perspectives and about the specific targets of the composite industry that are that the most important companies are facing now. So as a starter to the discussion, I would like to outline some aspects that I think will be important to be covered during the discussion. There are three of them. First, where do we go with the new materials? these three aspects, I would propose that every attendee, every participant of the panel discussion will cover more or less in the presentation. I know that some speakers will present the presentation, some will speak without the presentations. That is not very important. So where do we go with the new materials, and are we on the right way, or do we overestimate the role of the composites? Do we need these innovations, or can we still be somewhere with the traditional materials? Second, I would offer our speakers to focus on the role of the composites in reaching the goals of the sustainable development. The sustainable development is very important now. It is, let's say, not, I will not overestimate the value of the sustainable development if I say that the green agenda and ecological aspects are now everywhere. So all the subjects we cover, we think about the sustainable development. And third, let's try to give our guests, those who listen to the panel discussion, the insight, evident priorities and trends in the composite industry. We are all from the composite industry. I mean, everybody who will speak in this panel discussion, so everybody has their opinion. I would offer to share this opinion about the most important trends and priorities. So my first question will be to Anton Moskvin. The global, as I already said, the global agenda now is focused on the sustainable development, and we know that some time ago, Rosatom joined the United Nations Global Compact. This is the largest international initiative in the area of the sustainable development, and a part of the Rosatom activity is related to sustainable development, and covering the most important goals of the sustainable development is the green energy, the new energy type, that is hydrogen. So my question to Anton is, what does Rosatom do now in the area of the hydrogen power? What is the status of the current project? Is there any project now? And what is the role, and is there a role of composites there in the green hydrogen energy?
Yes. Good morning, everyone. Yuri, thank you very much. First of all, it's my pleasure to be here today with you, and I think that composite materials is definitely one of the pillars of the modern industries in many different fields, and hydrogen being one of the most important topic for the energy sector, of course, is planning to rely hydrogen energy and industry, of course, is planning to rely on the composite materials. Answering your question, yeah, I may, before starting my presentation, I will definitely support that the green agenda is dominating, positively dominating many markets and industries in a good way. We see increasing demand for the energy transition technologies, goals, pilot projects, governmental policies, and hydrogen is becoming more and more popular within such a context of the green agenda. And of course, for Russia, this topic is also very much important. For Rosatom, this is one of the strategic priorities already, both in terms of the development of the technologies and in terms of the development of commercial projects. So very much concentrated on this issue. And I see very good links in between hydrogen industry and the composite materials industry, as I said in the beginning, and I will try to describe our current state of events and how both our sectors might be integrated. So first of all, hydrogen, let me pitch a little bit about hydrogen, because I think not all of us understands in detail this new rising industry. It has lots of different merits, but I think three major of those. The first is hydrogen may be produced and consumed, transported and stored without any carbon footprint. We have already a set of technologies which provide for that. Second is that hydrogen has quite a high energy density, and it may be easily considered as one of the best accumulators of energy in several applications. And third, hydrogen might be easily transported to the very long distances. It may form a huge ecosystem of different industries interlinked with the international supply chains. That is almost impossible to transport energy from one continent to another these days, unless you use accumulators. But what we currently have for this kind of purpose is almost nothing but the lithium-ion accumulators with their own advantages and disadvantages. Hydrogen provides for the large-scale accumulation of electricity and energy, and provides for the international cooperation and international supply chains. One of the biggest advantages of hydrogen is it is very much versatile material. With the hydrogen, you may produce green electricity and may transport it to the different industries, may distribute the value among the different industries. You may produce electricity on the green power plant and supply it as the feedstock for the oil refinery or to the fertilizer plant, which was almost impossible before. And of course, the demand for H2 is rising. We see, you can see on the picture, the current forecasts show that even by 2030, we will have the increase of the volumes of hydrogen production and consumption from the current 75 million tons to at least 100 million tons, and it is going even higher. In 2050, you see the distribution of different forecasts is very wide, but at least in our assumptions, at least 500 million tons of hydrogen will be produced. This is a really big amount, and what is even more important is that it will bring the demand in the neighboring, in the linked industries like the composite materials, other new materials, of course being one of the most important allies of the H2 molecule. And here I'm talking about such technologies as the composite containers for the transportation and storage of hydrogen. You can store hydrogen in large volumes, and you can bring hydrogen from one place to another in the large volumes, and that is why large volumes of such composite materials might be needed. And what is also very much important is that half of the value of hydrogen, of the cost of hydrogen at the territory of the consumer, if we talk about international supply chains, belong to the transportation and storage. And of course, this sector, transportation of hydrogen, will involve composite materials, and here we see a very good link in between these industries. Talking about markets, in this part of the world, and talking about Russian strategy, we see our major markets in European Union and in Asia. You can see some of the figures here, but generally speaking, the demand for hydrogen in this region would not be provided by the local supplies. And some of the formal strategies of several countries in the European Union and Asia formally confirm that. There are several countries open for imports of hydrogen, which brings to the agenda the importance of international supply chains again. And Russia is planning to play one of the strongest roles in this field, and we're currently striving to become one of the leaders in supplies of both hydrogen and hydrogen technologies to this market. And in our assumptions, in the upcoming at least 10 years, the demand for the technologies for hydrogen production, storage, transportation, and consumption would be even higher than the demand for the commercial hydrogen as the feedstock material or as the accumulator. What about Russia in our internal program? We see strong support from the government right now. We have adopted the action plan for the hydrogen industry development on the governmental level 2 years ago, and it's being currently accomplished. Last year we have also adopted the hydrogen energy development concept, and the whole industry is currently working under the lead of the Ministry of Energy of Russia on the comprehensive national program for the development of low-carbon hydrogen industry. This creates the platform for many different projects and many different technologies development in Russia these days, and sharing the benefits of hydrogen technologies and the governmental incentives which are being planned to be provided for the developers of the projects. And currently there are more than 40 pilot projects announced in Russia in many different sectors, in production of hydrogen and in the utilization of it, in the transportation sector, in the industrial sector, and in energy sector. Some of the projects are meant to supply the H2 from Russia to the international markets. You can see on the slide there is a set of priorities, numerical priorities established for the hydrogen strategy, and which says that we will have a balance within the Russian hydrogen concept in between the local projects and export projects. And we see the demand for hydrogen not only on the export markets, but within the local markets as well. In our understanding, the major demand for the H2 will come from the industrial sector, mainly from the large metallurgical plants, from refineries, and from the fertilizer producers. And of course, a wide range of different technologies is being developed, and Rosatom is playing one of the key roles here. Our strategy presumes that we are developing the technologies for the production, transportation, storage, and consumption of hydrogen. In production, we are developing different ones: electrolysis, small steam methane reformers, carbon capture, of course, pyrolysis, and many other different. But for our today's session, I think that the development of gas holders and the cylinders for hydrogen transportation is more important, and we have calculated the potential demand for this part of the worldwide industry, and which exceeds huge figures of several 100,000 tons by 2030, and even more with the rise of demand for the hydrogen. Confirming that, I must say that we are developing pilot projects right now in Russia. Around 10 different pilot projects ideas are being investigated. We have done several feasibility studies in the sector of transportation, in the mobility sector, in the production of large volumes of H2 for the export purposes, with large metallurgical companies in Russia, which shows that this is something not only in the nice reports of the international agencies, but this is the reality which we are facing on the market. I'm really glad to be here with you and looking forward to cooperation in between our industrial sectors. Thank you very much.
Thank you, Anton. May I just say underline the key idea that I got from your presentation, that there are two most important areas to use composites in the hydrogen energy sector or hydrogen energy industry: the transportation and the storage. The transportation by means of the transport itself, the logistics, and we are saving weight there. We are trying to make it carbon free as well. So the transportation will need composites. I mean, trains or cars or whatever will be used for the logistic of the hydrogen. And second, the pressure vessels. Is it correct?
Yeah, can you hear me on this mic?
Yes.
Fine. Yeah, this is correct. I think that the major demand for the composite materials in the short-term perspective in this industry will come from the production of cylinders, tank containers, gas holders of different kinds for the local and international supply chains. And there are numerous projects confirming this demand. And Rosatom is already working on several projects of this kind, and I think that we will be facing the utilization of the technologies based on the products based on the composite materials in the coming years and the short-term perspective. This is not something really long-term. But this is something which will need very soon.
Okay, thank you. So we see that the pressure cylinders is the key part of the technology cycle, of the storage cycle, and my next question will be to the representative of the Italian company Faber, Luca Borelli. We are developing not only the hydrogen energy itself in Russia. We I know that different companies, not only Rosatom, are running some infrastructural projects, including some transportation projects that will require big amount of the pressure cylinders. We know that fiber industry is one of the leading companies in the world regarding the pressure cylinders. Do you use carbon aware of the current need? What is the need for the pressure cylinders based on the carbon fiber and the carbon fiber plastics? And what is your plan for the coming years regarding the pressure cylinders for the hydrogen energy?
Good morning to everybody. Do you hear me?
Yes.
Yes, okay. So, thank you, Yuri. Thank you for inviting me to this important meeting. Yes, cylinders are an important part for the future of hydrogen. Let me say that, okay, I present myself just a second. Luca Borelli. I work in a company, Faber Industries, based in Italy. We have 2 plants in Italy that are making cylinders, high pressure gas cylinders, not only in the sector of the mobility, but we also make pressure cylinders for other sectors like, for example, technical gases, medical gases, surface and underwater breathing apparatus, firefighting, and so on. Okay, today we are speaking about hydrogen, and today we are speaking about hydrogen, but hydrogen is basically the future. Basically, it's the future because there are many projects that are coming. An important point to develop this is the growing of the net of the refilling station for first, because the stationary is very important sector of hydrogen, because if we start for the concept to have a lot of refilling station, there is also an increase of projects about the mobility, about cars, trucks, buses, and all the other vehicles that can be fueled with a fuel cell, hydrogen fuel cell. So, speaking about the container themselves, I don't know if you are familiar, everybody, with the containers, but basically the cylinders are divided in 4 categories. The first one is the type 1 cylinder that is only a metal cylinder. Then there is the type 2, that is a metal liner, so-called liner, that is the container of the gas, wrapped on the cylindrical part with the carbon fiber. I say carbon fiber because normally it is much more used than glass fiber. Then there are the type 3. Type 3 cylinders are the metal container fully wrapped with the carbon fiber. And the latest one that is the most popular, let me say, for the future of hydrogen, that is the type 4, which means a plastic liner fully wrapped with a composite. So our company was a pioneer in the sector of the manufacturing of the cylinders, because we are design manufacturer of high pressure gas cylinders, as I said, and we started many years ago with the first project with hydrogen. We have been supplying since many years Toyota in Japan with their projects with the forklifts. Forklifts normally do not require a specific target weight, because forklifts does not need lightness. So we have been supplying, and we are still supplying, many cylinders only metal. But for example, in Japan, they require type 3 cylinders, so we use carbon fiber for their projects. Starting instead speaking about the real mobility from the cylinders used for buses, trains, and passengers, cars, trucks. This is the future that is still to be designed, let me say. Our company is able to make cylinders for application in buses and trains, for example, speaking about the pressure of 350 bar. Here, in fact, we are speaking about compressed gas, not liquid. So we make these tanks. 350 bar is the pressure normally required for buses, even for trains. Today for trucks, even though trucks most probably will move to the 700 bar, because when we speak about 350, 700 bar, of course, we are speaking about different hydrogen content, hydrogen weight inside the container, inside the cylinder. So you can imagine that if you want to make to have a certain autonomy of the vehicle, like it is necessary for a truck, it is of course necessary to have a certain quantity of hydrogen. Recent projects required up to 70, 80 kilos of hydrogen. So you must, by definition, go to the 700 bar working pressure cylinders, and because otherwise you would have the complete truck made out of cylinders. So it is necessary to grow with the pressure. Containers, basically, for the future of hydrogen are type 4 cylinders, so it means that a great quantity of carbon fiber is required, because if we speak about type 2 cylinders and type 3 cylinders, type 2 and type 3 cylinders have a metal liner that has a certain, gives a certain resistance to the complete tank. But when we speak about type 4 cylinders, the plastic liner is just a container. It is not a structural part of the cylinder. The structural part of the cylinder is given by the carbon fiber, completely by the carbon fiber. So when we move to cylinders for passengers, cars, and for even for fleets of commercial vehicles, but also, as I said, most probably for the trucks in the future, we need to use type 4 cylinders wrapped with carbon fiber at very high pressures. So today, passenger cars are developed mainly in Japan with the Toyota Mirai and in Korea with Nexo, but they are growing also towards US, Europe, and so on. There are some forecasts that say that most probably we will reach a level not far from the 12 million vehicles in 2030, fuel cell vehicles. So the important thing is to have containers able to be fitted in the vehicles Our company, of course, is able to make all these cylinders, but the most important thing and the most important role is made by the manufacturer and producer of carbon fiber, because carbon fiber is the element, the fundamental element for the growing of the hydrogen. And we speak about mobility, but we have not to forget the part related to the gas transportation and also to the stationary use of the cylinders, in the meaning that very often from the electrolyzer to the daughter station, it is necessary to bring the gas to the daughter station, so to transport the gas, and there are also the so-called trailers or containers that are equipped with high pressure gas cylinders inside. And all these cylinders, of course, considering the fact that it is necessary to save weight, will need carbon fiber because they are type 4 mainly. Also, you have to consider that an important role of suppliers of high pressure gas cylinders will be for the stationary application. In fact, if you want to have to fill a truck or a bus at 350 bar, you have to use buffers in the filling station able to keep a certain pressure for filling. So the buffers are made normally by cylinders, by pressure gas cylinders, and we make them. We make them up to 1,000 bar that are the one necessary to keep and to be able to keep the station at 700 bar for filling vehicles at 700 bar. And these cylinders are normally type 2 cylinders, but wrapped in the cylindrical part with the carbon fiber. So this is just a brief, let me say, resuming of what a manufacturer of high pressure gas cylinders can do for hydrogen. So in one word, everything. In the meaning that we are involved in all the sectors and we can do everything in all the sectors. Of course, there are some important aspects, and as I said, the most important is the development of the stations in order to allow hydrogen to go on with his growing, and the second one is the availability of the raw material, that in this case is mainly carbon fiber. All of that said, just the latest comment is that the future is to be written, as I said. For sure, hydrogen is the future. There is no other chance because we cannot think to go on with electric engines only with batteries. And the next challenge will be to remain within a sustainable level of cost in order to avoid that hydrogen remains just a niche for a small portion of the population.
Thank you, Luca. I have a small question, if you don't mind. Just to proceed with the discussion regarding how reasonable is it to use these expensive materials. We know that the carbon fiber is quite expensive. Carbon fiber and carbon fiber-based composites are much more expensive if we compare the weight with the traditional materials. And we know that you, as the manufacturer of the composite pressure cylinders, have all these numbers regarding how reasonable is it to use carbon fiber plastics. Can you give us these numbers just briefly? What benefit does it give to use the carbon plastic instead of metal or glass fiber? And what is the limitation factor? I mean, how much does the cost has to go down for the pressure cylinders to be everywhere, to substitute all the types of the pressure cylinders with the carbon fiber cylinders?
Yes, today, just an example, more or less today the carbon fiber has a price that was also recently increased by everybody. I see that many companies are now suffering of a big demand of carbon fiber, and I would say that with the latest increase, the price of carbon fiber is high, and from my point of view, we should at least I don't say half price of the market price of today, but not far up from that, in order to be able to keep a certain level of cost. Because, you know, more or less today, we are speaking about the cost of a container of more or less 500 euro per kilowatt hydrogen, depending, of course, on the dimension of the cylinder. But that is the number that is going on up and down in the different session of discussion and so on. We have to reduce that value. We have to reduce that value because in the part of the cost of the carbon of the carbon fiber in a cylinder made out of type 4 cylinder is in a big percentage. So let me say that if today the market price of carbon fiber is around the world approximately between the 20 and 22 euro per kilo, we should most probably not go over than the 13 euro per kilo to be sustainable. But I'm speaking about, of course, not the project of today. I'm speaking about projects of mass production, real big numbers. Because if we speak about the 12 million of vehicles, as I said, of course the demand of carbon fiber will be so high. So, you know, better than me that the price will be for sure down. Will go down compared with the one of today. So, I don't know if this was your question, if I am replied correctly to your question, if I answered it correctly to your question, but if you had...
Yes, thank you. It is clear, yes, it is clear that the price has to go down, the technologies have to be simplified, to be more cost efficient, and this will increase the reasonability of use of the carbon fiber in the pressure cylinders. Thank you for making this bridge between the global energy, from hydrogen energy to the practical applications of the composites. Now I would like to switch to the, let's say, high-speed applications, to the motorcycles, sport cars, and all that interesting area or that industry, global industry of the sporting goods. Unfortunately, we do not see because we are online, but you attending offline the conference could see this morning the beautiful motorcycles from MV Agusta at the entrance of the Russian pavilion. I would like to ask Brian, you are engineering motorcycles, you're engineering parts for the motorcycles for a long time. Now you use carbon fiber. We see the carbon fiber on the motorcycles. How far will it go? I mean, will you substitute sooner or later all the parts of the motorcycles? Where is it reasonable to use? Where is it not? Where will we see the traditional materials? And what is the trend, or what are the priorities of the companies like your in the carbon fiber area, in the composites area?
Hello, everybody. Thank you, Yuri. So I'm engineer Brian Gillen with MV Agusta Motorcycles. I wish we could be there with you today in Dubai, but we're connecting here via video. So in MV Agusta, we're a future-focused mobility and motorcycle manufacturing company. We've been designing and developing motorcycles and applying carbon fiber components for over 22 years. So the technology and application of carbon fiber components in production motorcycles has been one of our, let's say, core technologies, part of our strategic vision. of the company for over 22 years. And the original driver, let's say, behind the objective to apply carbon fiber for our motorcycles was two main points. The primary one was we're a performance motorcycle company, and Newton's second law is still an important, let's say, factor in the designing and developing of our motorcycles, both for street and racing, and that's F equals ma. So if we want to have more acceleration, we need to try to reduce the mass of our bikes as much as possible. And back in 1997, 1998, 1999, at the state of the legislation at that time in terms of exhaust emissions and noise emissions and so forth, it was enough to use carbon fiber components as components to reduce the mass to increase the performance of the bike, while at the same time from an aesthetic or a styling point of view. So the main focus at that time was styling and performance. What's happened over the course of the past 22 years, as we know, is that European and global legislation has become much more strict in terms of noise emissions, as well as in terms of exhaust emissions. And what that means is what we've had to do is try to continue to tailor and change our focus, not only from applying carbon fiber in traditional, let's say, a manual layup in an autoclave way for styling components or in components to reduce the mass of our production, high-end production or our racing bikes, but to also take into account the external pressures from legislation to try to reduce as much as possible the mass of our production bikes, because the reduction in mass has a big impact also on the factors that define exhaust emissions. As the mass of the bike comes down, the amount of energy required to accelerate the bike during emissions test cycles is less. And that allows us to also have an impact on exhaust emissions and legislation. So it's played an important part, let's say, in the beginning of motorcycle and mobility from styling and performance, and it's becoming ever more important in terms of meeting current and also future legislation as we come up on, we're right now in Euro 5, and the motorcycle industry will be passing into the Euro 5 Plus, and then the Euro 6 emissions requirements, and it'll be even more important at that time.
Thank you, Brian.
So the future of composites in the area of two-wheel mobility, you know, is really interesting because, as we stated in the beginning, it started out as a styling and reducing weight. The motorcycle industry, and especially the performance motorcycle industry, has come to or exceeded the tipping point of available power and available traction. So what's happened over the course of the last 6 to 7 years in the motorcycle industry, as the performance has now exceeded the available traction of the rear tire and the tipping point of motorcycles trying to tip over backwards as you accelerate. So due to that, we've had to refocus our engineering on motorcycles, not only in terms of reducing weight to increase the acceleration. Then we came to the point where the acceleration is now so high that the limiting factor is the bike trying to tip over backwards. So at that point, we've had to now introduce more aerodynamics, which into the design and the development of our two-wheel vehicles, motorcycles, introducing aerodynamic elements on the front part of the motorcycle to generate downforce, to allow us to then increase even further the acceleration of our bikes from a performance standpoint, both from racing and for our very high-level production street bikes. And in order to have structural styling components on the bike, we need to apply new technologies. And those new technologies are carbon fiber reinforced body components. Carbon fiber reinforced body components that have to be scalable for production motorcycles, not just for very limited racing motorcycles. And to scale it, we need carbon fiber components that are also done with thermoplastic resins that can be scalable from a production standpoint. So that we're not just doing manual hand layup of very high-end motorcycles, but matching new processes with the carbon fiber technology in order to scale up the production volumes of our motorcycles in this segment.
Okay, so we see that the whole concept of the motorcycle is changing because of the availability of the new materials. Is it correct?
Yeah, this is correct. In order to meet, like we said, external factors of legislation and of performance, and the motorcycles need to start adapting even more so composite components in order to aid us to meet and exceed the requirements coming from these external factors.
I see. So this is the example of where the technologies come from the, let's say, professional area to the more practical, the more mass use, the carbon fiber from the race motorcycles, and the technologies of using carbon fiber are going slightly to the more mass market areas.
Correct. It's the materials and the processes that are allowing us to bring this even more further into the mass market products and scale up to make higher volume motorcycles applying these technologies.
We have another person who is professionally involved in the racing motorcycles industry in the whole, Mr. Puccetti, Manuel Puccetti, from the Italian company or Italian racing team Kawasaki Puccetti. The question, my question will be related to the carbon fiber, of course. But first, I would like to know your opinion. Will we see soon, or does it exist already, the hydrogen-powered motorcycle?
Hello everyone. I'm Manuel Puccetti, founder of Kawasaki Puccetti Racing Team, team involved in World Championship Superbike. Our team was born 20 years ago, and last almost 10 years we are involved in the World Championship Superbike in all classes. We are a two-time world champion team, and we born our collaboration with Humatex almost 4 years ago, and together we study the new carbon fiber fairing for our bike, Kawasaki bike in World Championship Superbike. In the beginning they study a lot, and they think to come with the fresh air, new material, new performance material to develop our bike, our aerodynamics also on the bike, and in the end, we reach our main goal together. We improve step by step this part of the bike, the carbon fiber fairing, and then test by test, we find a way to find the best performance of this package, performance and also weight, aerodynamics. And then luckily we did together, we reached the main goal as we won race in World Championship Superbike in the main class together with the Humatex fairing. And this is something that make very proud our collaboration, and this is just was the start of our collaboration. Now getting more and more and more, and I believe in the future will be again work together with find a way out again to find the best performance to all carbon fiber material in our motorbike. Coming to hydrogen power, the moment is not yet involved in the World Championship, but I believe as we saw already existing the electric motorbike race in World Championship, the Moto E championship on site of MotoGP championship. So I believe in next 5-10 years will come also this possibility to ride with hydrogen bike, I believe. Thank you.
Thank you, Manuel. Propose that we switch now to another industry that is very important and very, let's say, material consuming worldwide, the shipbuilding industry and the marine applications. We know that I think there's no modern vessel or no modern ship that avoids using composite materials. it is obviously reasonable to use carbon fiber, or not only carbon fiber, but glass fiber as well, in the structural elements of the ships. But these vehicles are very big. Is it really true that we need composite materials there? What is the perspective of using composites and carbon fiber-based composites in the marine industry, and what is the situation there regarding the composites? The question I would like to address to Albert Nazarov.
Yeah, hello. Is my presentation on the screen?
Not yet, but I think it's coming.
Yeah, it should be there. Yeah. So, because I represent the marine industry, okay, the shipbuilding industry here, I would like to say that we are probably one of the most conservative industries in terms of using the composite materials today. However, I am in composite designing of composite ships for more than 20 years. So we are one of those who really trying to give a technology push and change the industry at the moment. The industry, maritime industry, is completely designed around steel ships at the moment. And let me show you the presentation and show some possibilities and challenges and the perspective projects which we can develop in composite materials. Can I get my presentation on the screen, please? So, because I don't see the presentation, I will just go ahead. Elena, do you manage my slide? Okay, so let's go ahead. We go to slide number 2. Advantages of composite materials for the maritime structures. First of all, composites are very resistant to the unfavorable maritime environment. They do not corrode. There is no rotting. So this is one of the reasons why we would like to use them for the marine structures. Then composites provide seamless, complex shapes and very nice shapes as well. So that's why they are widely used, for example, in the superyacht industry. Then once we design the structure in composites, we can tailor fit it to the loads and optimize the weight to suit the loading conditions. Very light structures we can create, and they are very durable and easy to repair. And of course, especially for the naval applications, it's important that composites provide very low magnetic and radar signatures. However, there are common disadvantages. Some of them come with question mark, of course, but first of all is the recycling, because the ships, they are basically quite large structures and we need to recycle them, and composite materials are not really well recyclable at the moment, yes. Then the biggest issue for the regulatory issues now is the combustible. The composites their performance in fires is not so good. Then we also have to look at performance at low temperatures. However, there are solutions to make the composite structures even for the ice applications. And there are also cost of tooling involved in composite ship manufacturing. Next slide, please. Here is the timeline of the for the composite structures in shipbuilding, how it grew up and developed. In first attempts to build boats and ships in composites, they basically started in 1930s. But I would say that so wide application of composite materials, it was 1950s, 1980s. That day it was called GRP, glass reinforced plastic. Mostly was used to produce the small boats, recreational craft, some naval vessels, and the advantage that day was seen as low-cost material suitable for mass production, mostly based on polyester and glass fiber with handling up and very high structural margins. However, in 1990s, the situation started changing, and the maritime industry started switching to the multi-axial glass fibers and start using carbon fibers, switched to vinyl ester resins, which are more resistant. We start using the core structures very widely and introduced vacuum infusion. And the main advantages of the composite structures became weight reduction, low cost of maintenance, and low magnetic and radar signatures. So right now at 2020s, we are looking at using carbon and glass fiber combinations. We are looking at variety of the metrics and cores, vacuum infusion and weight optimization. And of course, these materials are expensive. But right now, we are targeting at fire resistance and weight reduction, and again, low maintenance cost and some other features. So it's growing, it's developing, and I would say that in next years we will see large changes in the maritime industry in terms of the composite materials. Next slide, please. There are a few areas where the composite materials are applied in the maritime industry. I would divide them into three groups. First group is the area of widespread application, which is mostly recreational craft and some racing yachts and some components for the recreational boats. That has been used for decades and is subject to quite soft regulations, so it's widely used and widespread. And then next group is the area of proven technologies. What I say, it's use of composites for the craft, for the vessels which are not governed by the international conventions. For example, like passenger vessels used on domestic routes, naval ships which are out of international regulation as well, some cargo vessels, and then the perspective group where we are working right now, and I think that mostly most of maritime community is looking at the biggest share of the composite market for the maritime industry, is the area of perspective technologies. These are the vessels which are involved in international voyages and are subject to international conventions such as SOLAS. And they already started some tests and some R&D producing the elements of ship structures, some hardware and equipment such as hatches, doors, and maritime containers are on the table. However, this group is severely limited by the regulatory restrictions at the moment. We will look at them in a few minutes. For us, as the designers, we have been involved in this design of mainly for the first and second group of vessels, starting from yachts and some passenger vessels, for domestic routes, fishing vessels, some patrol boats, and we also did some interesting racing craft and some interesting craft with, for example, electrical propulsion. Next slide, please. So here are the images of the craft we have designed in the recent years, showing the spectrum of applicability of the composite materials to different types of vessels. There are some pictures of these vessels. Can we have next slide? Cost of manufacturing. Okay, so cost of manufacturing and maintenance. Here is the diagram showing the comparative cost of structures in different materials. It's often referred that composites are expensive. compared to steel and compared to aluminum, this is why they are not widely suitable for the maritime industry. I think it's a big misunderstanding, because if we look at the cost of kilogram of structure, composites are more expensive. However, the composites themselves, they provide significant saving of weight of structure. The composite structures are much lighter than the structures designed in other materials. Next slide, please. Here we talk about weight saving. Weight saving is the key advantage of the composites for the maritime industry. First of all, it provides, for example, it's a part of the green thinking. So we need for the lighter vessel, we need less power. Okay, we can carry more cargo, or we can put more power cells in the vessel. So it's a key feature in the development. Here we show the comparison of structures in aluminum, for example, and composite for some high-speed craft. And one can see that the saving in weight compared to the aluminum craft is about up to 30% for the catamarans and up to 15% for the monohull vessels. If we compare to steel, I would say that composites provide up to 30% of weight saving to equivalent steel structures for large ships, and 3 times less the weight of structure for the small craft. So it's a massive saving, and it should be really the future of the maritime industry. Next slide, please. Then one of the biggest advantages is the cost of life cycle of the composite ships. Though the initial construction cost of the composite ship might be slightly higher compared to the steel ship, but the cost of life cycle can be up to 30% less. This is due to, first of all, less maintenance required by the composite structure. So it's another huge reserve and huge potential of the composites in maritime industry. Next slide, please. This is quite interesting story, I would like to say. You know, when we talk about composites in the maritime industry, we always hear the opinion that composites are not suitable because they burn. Yes, their resistance to fire probably have to be improved. However, in the 19th century, we heard the same story about the steel ships. They say, oh, we should use wood to build our ships because steel sinks. Now we have the same thinking applied to the composite materials. I think probably are the same people because skeptics never die, you know. So we really have a technology push here, and we need to. There is a demand for new approaches in design and regulations. So we really need to look at something new and change the approaches to the maritime composite industry. Okay, next slide, please, where we have the major limiting factor. I have done the comparison of the regulations for the major limiting factors in the application of composites in maritime industry, and of course it's the resistance to fires. And here we can say that, of course, for the vessels regulated by the SOLAS Convention, which are subject to international shipping laws, there is very little space for the composite at the moment. However, there is quite a lot of space for the domestic vessels, for the naval craft, for the even for some vessels with innovative features. Next slide, please. Composite engineering. At the moment, we as industry are ready to design and develop complicated composite structures, I would say up to 100 meters of length. There are well-proven methods. There have been done a lot of research and a lot of testing. So the industry is ready. The industry is ready to move. Once we remove the administrative, the normative barriers, we are ready to go for much larger vessels. And the next slide is the perspective designs. As the designer, I would say that I see the major potential in composites for the next years in the development of high-speed craft, and also with in development of some special craft, such as like a solar-powered vessels, where we can get significant weight savings. We can install more batteries. We can carry more solar panels. Is also the green energy solutions, and of course to the yachts. Yacht industry is basically 90% on the composite materials already. So that's all. Thank you for your attention. And if there are any questions, please go ahead.
Albert, thank you very much for the very complex presentation. You covered all the aspects that we are going to discuss during this panel discussion. Thank you very much. The only one issue or small question. Do you comply within your company with the sustainable goals, and do you use the tools of the sustainable development, like financial tools, for your development, for your engineering projects, with the special financing proven by the use of composites for the sustainable development?
You see, we are a design company, and we are not only engineering company. So sometimes we have to offer solutions for which probably no tools exist at the moment, and we try to create the tools ourselves as well. You know, so we are. I would say we are at the front edge of research of using the materials. We have introduced some solutions in the composite engineering and ourselves. And in fact, I'm a member of the work groups for developing the standards for design of the composite ships as well. So the tools are being developed at the moment. There are no fixed tools, you know, which we use. This is something that is growing, and we really need to push it. We need to push the industry, which is very conservative. We need to push the industry to change, and we are one of the people who are doing that.
Okay, thank you very much. Quite impressive. Thank you.
Thank you.
Vittorio Torambini represents many Italian companies here. He, as I said in the beginning, he is the president of the, let's say, the cooperation of the Italian, many Italian companies in Russia. So he knows what happens in the Italian industries. My question will be related to the shipbuilding and marine applications as well, because we know the beautiful racing cars, motorcycles from Italy, but there's not quite often mentioned the achievements of the Italian industry or Italian engineering in the shipbuilding. What would you say? How will you inform us about the current status of that area of industry in Italy, and how does this industry use the composite solutions?
Yuri, спасибо за помощь.
Yuri, thank you very
much. Yes, don't worry, that's fine.
Okay.
During the presentation.
Yuri, совершенно верно отметили.
Yuri, thank you very much. Italy indeed is one of the top countries of shipbuilders. We create all of the lines of shipbuilding, cruise yachts, passenger craft, and of course we're using new technologies and materials, including composite materials. Перевод. Italian manufacturers use composite materials not only for shipbuilding. And of course, you've already named all of the benefits of composites. They're resistant, they are light, their life cycle is longer, and it affects aerodynamic and flexibility, maneuverability of the craft. It all leads to more efficiency. So, using components in various industries helps us achieve sustainability goals and net zero goals. I would like to mention one more thing. Since I am witnessing what Humatex is doing, for example, Russian producer or Humatex has today created a complete line of composites based on carbon fibers, and they are one of the leaders in composites. Last year, they commissioned a plant that produces a special fiber to further produce carbon fiber. Humatex is also producing carbon fiber. And they also manufacture ready-to-use products for construction industries and other items. The company is being developed actively within the recycling cycle of composite materials, so they want to give them the second life, which is an important step towards green industry. The products of Humatex are also being used by Italian manufacturers. For example, PMT SPR company is dealing with shipbuilding in Italy. They use hybrid carbon fabrics produced by Humatex. They are used in San Lorenzo yacht. Other Humatex products are used by LTD company to produce auto accessories. And in general, this cooperation helps us to create energy efficient products and support the development of green energy and achieving our net zero goals. I would like to add that there is a company that helped the Italian companies to develop some manufacturing equipment, because Italy is one of the leaders not only of yachts but also in equipment, so it's very important to be partners with Humatex. Thank you. Thank you.
Not only shipbuilding and marine, but other industries, and thank you for mentioning Humatex activities in Italy within our joint projects. The next industry that I'm going to enter is let's say, one of the most interesting and exciting for the development. We, as the conference is taking place in Dubai, that is the civil construction miracle for the last 20 or 30 years. We see the skyscrapers, we see how infrastructure changed in United Arab Emirates for the past 50 years because of the new technologies, because of the speed these technologies were integrated into the civil construction. And this could not also happen without the new materials. We have a person who is very experienced in the civil construction composite applications, Valery Gurinovich. And I would like to ask Valery to share the thoughts about the perspectives, the priorities of the civil engineering and composite applications in civil engineering within your company and in the industry worldwide.
Good morning, everyone again. So my name is Valery Gurinovich, CEO of company Garlin. Quite interesting dynamic discussion about the high-end and high-level carbon fiber and composite material, but let's make it a bit boring. Going back to the basics, to the application of FRP materials in civil construction, and spending the next 10 minutes talking about and observing the industry, the niche applications, and a bit of history, what was happening in the last 20, 50 years. So let's start. So application of FRP materials in construction. In that particular case, we can underline three major topics. So first of all is external reinforcement of structures, FRP reinforcement, and as itself production of architectural and structural elements from composite material. So first of all, external reinforcement of structures, and what needs to be said here, that over time loads induced by everyday wearing process negatively affect the condition of pipes, bridges, reservoirs, buildings, and other structures. In such cases, FRP materials are used for strengthening, repair, and rehabilitation of damaged structures. External reinforcement is performed when a structure loses its initial design strength, and using this method makes it possible to restore and desired structure strength. In some cases, the conditions of structures which underwent external reinforcement exceed one of newly built structure. FRP reinforcement. So reinforcement is added to a concrete structure in order it can withstand bending forces. Concrete is strong against forces of compression and has low tensile strength. That is why concrete should be used together with a construction material which is strong in tension, and that is reinforcing bars. Reinforced bars should be installed in a tension area of bending concrete element. And FRP or composite reinforcement, it might be also basalt or carbon fiber bars as well. This is a direct substitution of steel rebars. FRP reinforcement provides the following advantages, like the 2 times higher tensile strength, 4 times lighter, definitely corrosion-free, environmentally friendly. Production of architectural and structural elements from composite material. Nowadays, composite material are widely used in onshore and offshore construction as a structural elements to minimize maintenance expenses and provide a high capacity safe environment. The unique properties of composite materials are being utilized in decorative elements with a very specific needs as well. So what is FRP rebar? So polymer composite reinforcement is a non-metallic rods of continuous fibers bonded with the thermoplastic or thermocertain hardened polymer binder formed on a surface of the rod-ribbed or epoxy-sanded coating for adhesion to concrete. Fibers that provide strength and rigidity to the rods might be glass, basalt, carbon, or aramide. And a matrix provide connection between fibers and protect them are polyester, epoxy, or vinyl ester. There are lots of areas of applications. FRP rebars can be used as an alternative to steel rebar for reinforcement of concrete structures. FRP rebars are used to reinforce of infrastructure project and external design lifespan, corrosively loaded structures, foundation and rolled slabs, object with unacceptable electromagnetic pollution, and object with high requirements for thermal conductivity. Definitely, the use of composite material helps to reduce constructive time, cost of the structure itself, operating cost, and safe of installation, and definitely transportation. So a bit of background. So FRP materials gained wide use after the Second World War. In the 1940s, the aerospace industry recognized such advantages of FRP materials as high strength and lightweight. In the 1960s, FRP materials were considered as concrete reinforcement, start to be considered. The reason was the development of automobile road system. Use of de-icing salts and exposure to sea salts using road bridges results in extensive corrosion. It posed a huge problem and led to considerable cost for maintenance. Advanced technologies of the 1980s required a non-metal reinforcement. The highest demand for the electrical insulation reinforced medical devices, in particular magnetic resonance images. And in the 1990s, FRP reinforcement was again considered as a comprehensive solution to corrosion of bridge decks and other structures. Now, FRP materials have been widely used in construction industry. Raised interest in FRP reinforcement as a complete concrete reinforcement material was caused by the following reason. Low durability of steel reinforced concrete structures operate in aggressive environment due to corrosion of steel, high cost for repair and protective measures to ensure corrosion resistance of steel reinforced concrete structures operating in an aggressive environment. Inapplicability and ineffectiveness of steel reinforced in special facilities, and limited iron ore resources. Sorry. So FRP materials and their impact on environment. So we can underline two major topics here. So it's instantaneous effect such as that during the production of FRP reinforcement itself, CO2 emission into atmosphere are insignificant. According to residual environmental data, FRP production produce from 4 to 5 times less CO2 emission than steel rebars of the same diameter. Besides use of FRP reinforcement, a thinner concrete layer is required, which makes it possible to decrease concrete consumption and therefore to reduce carbon footprints as well. And the long-term delayed effect. Structures constructed with FRP materials have longer service life, required less maintenance and common repair, which results in minimal use of new construction materials, equipment, electrical power, and etc. So I would like just to emphasize some implemented projects, and some of them were done in that particular region. So first of all, there's the reinforcement of pool walls of Louvre, Abu Dhabi, in Art Museum, done in 2016-2017. The museum was designed by John Novell, the winner of Architecture Prize, and the museum is located in the seawater. The absolute resistance of FRP mesh to corrosion was really crucial in that particular case. So the upper concrete layer of pool walls was reinforced with FRP mesh produced by company Garland, and exactly it was 2.2 millimeter diameter and 50-50 millimeter opening. So one of the hugest projects ever made with the FRP reinforcement is the mitigation channel in Saudi Arabia, and that was finished in 2019. So the major purpose was to mitigate the water, so the water mitigation channel to prevent from flood during the rain period. So the length of that channel is 21 kilometer. The customer is a Saudi Aramco oil company, and the major product was 13 millimeter diameter bar, as well as band bar to concrete reinforcement. In that particular case, any bar that can be used definitely had to be compliant with the requirement of international standard ASTM D7957. So different project made in Russia as well. So reinforcement of foundation slabs of high-rise apartment building in Moscow. Typical townhouse that we reinforcing together with other providers in different parts of the United States, such as that in the center of Miami is fully reinforced with the composite rebars of our company. And by the end, what I would like to add, so that the world FRP materials market increased annually by 6 billion at average in a final product. Currently, the world FRP materials market is estimated more than $100 billion annually. Products for construction and transportation are in great demand in the world GFRP market. Thus, the share of construction industry is equal roughly to 37% of the world FRP market. But the share of the Russia in the world FRP production is still about 1%. Thank you for your attention.
Thank you, Valery. Very complex presentation. I think we can give the opportunity to ask some questions from the audience to the speakers if we have. If not, then I would like to cover a little bit additional areas that were absent during this discussion, but they are traditionally covered on the composite conferences and composite panel discussions. The first, of course, the aviation. Unfortunately, we did not succeed to bring to this panel discussion the representative of the company of EXPO Engineering due to the pandemic limitations. But I would like to underline the key priorities in the aircraft engineering and aircraft manufacturing that I received yesterday from our experts that are working for the aircraft composite industry. So first is the thermoplastics. Same as Brian said, the thermoplastics and the fast manufacturing, that is second priority, fast manufacturing processes are two main technical priorities or technical trends for the aviation industry. Yes, there are some limitations to use thermoplastics now because of the high temperatures, because of some performance issues, but there are new thermoplastics appearing on the market, offered by the manufacturing companies, and we see that they will take their part of the industry soon. We see that the use of the carbon plastics in the aviation is raising now from 10% 30 or 40 years ago to 50%, even exceeding 50% now. We see that all the benefits of the composite applications, especially carbon fiber plastics applications, are very obvious for the aviation, for the aircraft building. So it is sustainable. It gives fuel consumption benefits. It gives zero footprint benefits, and carbon fiber will be used, especially I would say, and I would make the specific priority for that, the hydrogen power for the aircraft engineering will bring another fresh impact to the use or to the growing demand for the composites in the aviation industry. Second industry that has to be mentioned is the the wind blades. The wind blades that are now made from composites, mainly glass fiber, with the reinforcement from the carbon fiber, and that makes and that brings benefits and some problems with the combination of glass fiber and carbon fiber. They are hardly recyclable. The combination of the hundreds of different materials in the wind blade makes this blade very difficult to be recycled. That's why they are kept now in the specific areas in the deserts, and this is a big problem for the industry. So the next step that we see, and this is our view, as we are the composite company as well, is that the simplification of the manufacturing process for the wind blades, the simplification for the transportation of the wind blades from the manufacturing point to the point where this wind blade will be used, and the ability to recycle the wind blade are the three priorities for that industry. And we are going to follow these priorities and to offer something to the market soon. And the last area or the last industry that we started to discuss, but we did not go into it because I supposed to be the speaker for this panel discussion to cover this area, is the sporting goods. The sporting goods for our company. So we started the manufacturing together with a partner. We are manufacturing now the hockey sticks and some sporting goods related to the ice hockey. Is a kind of the base camp where we develop the new technologies. All the priorities that were mentioned by all the speakers today, the fast manufacturing, new materials, recycling aspects are true and are also the priorities for the sporting goods. The good point there is that we can try and we can develop the new technologies, we can implement the new technologies in the sporting goods much faster than within the big industries like energy, shipbuilding, aircraft manufacturing. So we already see that the trials for the new manufacturing processes are running much faster within our company for the sporting goods. So that's why we will use the sporting goods to develop new technologies. And of course, recycling of the composite parts, of the composite, especially big parts from the shipbuilding industry and from the aircraft industry is very important. It is the most valuable part of the all sustainability subject that we try to cover today. So let me share my thoughts and ideas and notes that I made during all the discussions for the three aspects that I started to mention in the beginning. That definitely composites are valuable, the use of composites is reasonable, and the issue is the long life cycle, the feasibility study, and the correct calculations on how to use and where to use composites. Second, the goals of the sustainable development, the composites align with these goals for the 100%. So they make all the technologies more sustainable because of the lightweight, because of the economy, and because of the social aspects, because we provide the growth of the high-tech technologies using the composites. And the technical priorities or the view on the trends of the technical development for the composites that I made during the discussions is the following. First, thermoplastics. Second, fast manufacturing technologies, fast curing resin systems, and all that stuff. Third, from Albert, hybrids and combinations of different fibers and the composites, especially for the shipbuilding and for the marine industry. And the fourth is recycling. Recycling for all the industries, from the civil construction to the hydrogen energy is valuable for the composite materials, because the biggest difference between the composites and conventional materials is now the availability of the recycling. So that's mainly the goals or the result of the discussion that I see from my side. If anybody from the audience or from the speakers would like to add something to these priorities, I will be happy to give this opportunity. Oh, I see that somebody.
Dr. Vitaly Konovalov.
Dr. Vitaly Konovalov from the Export Control Group.
Here in Abu Dhabi. There was a lot of aspects covered, and I would like to mention one more. This technology is because of its origin, which you know better than me, it's considered to be a dual-use material. So there is still a non-proliferation aspect on this, and I would like to ask how you cope with this restriction.
If you don't mind, I will start. I will try to give you the answer, because we are using different types of materials. We are using not only carbon fiber, we use glass fiber and basalt and all the rest. And we see some limitations only within some technologies with the carbon fiber. So carbon fiber itself is the product of the dual use because of the international regulations. All the rest, including the technologies themselves, is not a subject of the specific limitations for the international use. Yes, there are some military technologies within the composites. There are some applications that are not easily transferred between the borders, but they are same strict or same way of regulations as within the traditional material. So there's nothing specific within the composites and composite technologies themselves. I mean, if we compare composite technologies with the ceramic technologies that are by most of the means is the dual use, composites are not that limited, except the carbon fiber itself. Some types of carbon fiber exceeding some levels of tensile strength and tensile modulus are limited to be exported and imported to some countries. So we are, in fact, 8 minutes exceeding the schedule of the panel discussion. I would like to thank all the speakers for the very interesting presentations, very interesting ideas and thoughts. Thank you for visiting our panel discussion. Thank you for listening. I hope that this discussion was valuable, and I hope we meet again on the next events that we will hold within the composite events that happen every year. And I hope that we will meet in person, not online. Thank you very much.
Thank you very much, Yuri.
Thank you, everyone.
Thank you, all our speakers. Thank you for this wonderful discussion. And I would like to invite everybody to the coffee break. You can see the door is open for you. Enjoy, please.
Thank you, Lina.
Blue jean baby, LA lady, seamstress for the band, pretty eye, pirate smile, marry a music man, ballerina, hoping for the best, but expecting the worst. Are you gonna drop the bomb or not? Let us die young, or let us live forever. We don't have the power, but we never say never. Digging in a sandpit, life is a short trip. The music's for the sad men. Can you imagine when this race is won? Turn our golden faces into the sun, praising flesh, it takes hold of my heart.
So I guess we can start. We can start right now. Thanks a lot for coming. First of all, I want to welcome everyone at Rosatom Week International Pavilion EXPO 2020. We want to start our panel on the wind energy here in Rosatom Week. So first, with a global consensus on transformation towards the renewable energy, wind energy becomes one of the key sectors of the transition. So the market becomes increasingly competitive as many investors with big appetite enter the market from traditional sectors, from oil and gas sector. Rosatom is also on the market from 2017, and I must say that we achieved really good results, which we will talk about later. Increasing number of investors leads to a global drop in the long-term contract prices in countries around the globe. What we can see from the tenders, the price right now for the long PPAs with the government is somewhere around $35 US, which is quite competitive In the developed countries with large RES fleet already, we see that the government's support of the industry decreases, so it becomes really competitive to get the financing from the banks, as there are no long-term PPAs, and you need to somehow to prove the revenue for the banks to get the financing from them. To the other side, to see the increase in the costs, because COVID disruption ended up with the increased cost almost on every part of the equipment and other resources. Also, there are increase in inflation rates, which leads to the increase of the bank rates, which also doesn't help us to make the projects. To the other hand, we see the consolidation of the product lines of different turbine producers. So in the end, all the investors are compete only in the field of the cost of funds or borrow it. So we asked industry guys from around the globe, both on developer side and on the financial institution side, to join us here and to talk on these issues and see what we will get. So first of all, I would like to give floor to Mr. Igor Ginkevich, Deputy CEO of our company Nova Wind, Rosatom division for the wind energy, and he will present you the information about our company and our plans for the future development. Please.
Hello, colleagues. Excuse me, I'll speak Russian. I think that here is a translation.
My name is Yegor Grinkevich. I'm the Deputy CEO on technical and regulatory development of Nova Wind Company, which is the main operator in the area of wind power in Rosatom. Wind energy is the so-called new business of Rosatom. And these new businesses are growing quite fast. In 2020, the share of the revenue from new businesses so the share of the revenue from new businesses was 23%, and according to forecast, by 2030, the revenue share will be up to 40%. Wind power is one of the main areas in the new businesses for Rosatom, alongside with the composite materials and additive technologies, power storage units, digital solutions, and a number of other areas of development. Speaking of wind energy, Rosatom entered this business in 2013 as part of the program for the support of renewable energy, which was started in the Russian Federation. It has competence as an industrial producer, as a generating company, as an operating company. It has these competencies, and with that, this was a well-balanced decision to enter this new business. As one of the main conditions for the support in the Russian Federation is localization of production of wind power equipment, and of course for Rosatom that would, as an industrial corporation, that was important. The basic technology was the technology from Lagerwey. It is currently a unit of the Enercon, a German concern. The wind power unit for 2.5 megawatt. It is based on the direct drive technology. It is a light structure, and it has a modular tower. These parameters actually provide good competitive advantages both inside the Russian Federation, and it also provides access to international markets. Furthermore, there is potential for the development and production of a 4 megawatt unit from the same manufacturer. When implementing this program, Rosatom created a production facility in Volgodonsk, the plant of the JV Red Wind. It is a JV of Rosatom and Lagerwey company. It produces generators and it assembles certain parts of the wind power, including the gondola and the hub. Furthermore, the Vetrostroy Detal factory, our partner also in the city of Volgodonsk, is producing modular towers for the wind power installations. At the moment, both production facilities are fully